Alright, this is section 2.1. In this section, we're going to learn a lot of symbols and terminology for the chapter. So let's jump right in. Okay, so it says a set is a collection of objects. The objects belonging to the set are called elements or members of the set. So there is going to be a lot of terminology, and once we start doing the problems, you're going to become a little more familiar with what are we talking about. Okay, so for example, here we have three different ways. Well, that's supposed to be a 2, sorry. Three different ways that we can write a set. Okay, so this is basically an example. This is an example. Okay, so the first one is a word description. So it says the set of integers less than -5. The second one is an example for the list method. So for the list, you will have basically a list of the elements. So in this case, notice how when you write a set, you're going to use brackets at the beginning and at the end, and the elements are going to be separated by a comma in between. Okay. And the set builder notation, not sure if you've seen this before, but it starts with the bracket, not a bracket, a braces, and then it has this straight line after x. So x, this straight line means such that, I'll write it right here, such that x is an integer less than -5. Okay, so notice you end with the braces again. So this is just an example of what we're going to be seeing and how the sets are going to be written either by a list or a set builder notation, or it's going to be a description. Alright, so now it says a set is commonly given a name. So the name is going to be a capital letter. So for example, if I have a set A is going to be basically the ABCs. The 3 dots in between means all the letters in between, but instead of writing them, all of them, they just put 3 dots. It continues the letters in between, basically. Okay. Alright, now we have natural numbers, which are your counting numbers, and we use capital N to define the set of natural numbers. Natural numbers are your counting numbers, so it starts from 1, 2, 3, 4, ... means it keeps going. Okay. Notice there's no decimals, there's no negatives, and 0 is not included on your natural numbers. The next one is whole numbers. We use capital W. Notice it's basically the initial. Capital W to define the set of whole numbers. And whole numbers is really similar to natural numbers. The only difference, you're including 0. Okay, and all your positive numbers. The last one is integers. We use I for this set, and that's going to be all your negative numbers, 0, and all your positive numbers. Alright, so those are examples of 3 different sets. It says the set containing no elements is called an empty set or null set, and is defined by the braces with nothing in between, or this looks like a 0 with a line through it. So I'll rewrite them right here so that way you know what they look like. So there's nothing between the braces, or there's like a 0 with a line through it. Okay, that means there's no elements on that set. That set is empty. There's nothing in it. Okay. Alright, so now let's start practicing how we can write a list of the elements in a set. So here we have 4 questions. I'm going to try a couple together, and then I'm going to highly encourage you sometimes during the videos to pause the video, try it yourself, and then check your answer. Okay, so let's look at the first one. It says x such that, remember that line is such that x is an integer between -8 and -4. Now be careful here. We have a hint here that you have to be careful. Between Between means it does not include the n numbers. So it does not include -8 and it does not include -4. Okay, now to write your answer, you're gonna, because it's a list, we're gonna start with the braces and we're gonna start writing all the numbers in between. So the numbers between -8 and -4 will be -7, -6, and -5. Notice I use commas to write them, commas in between. I start with the braces and I end with 1. Okay? Alright, so the next 3 problems, I will highly recommend you to pause the video right now, give it a try, and answer the questions. Once you're done, click play again so you can check your answers. Alright, so for the next one, number 2, we have x such that x is an integer greater than -6. So if we start writing numbers -6, greater than -6, so that will be -5, -4, -3, and it keeps going. All the numbers, -2, -1, 0, 1, 2, 3. So by putting 3 dots, normally we use only 3 dots and I put 4, sorry. So that says that it keeps going forever and ever. Okay. Alright, the next one, number 3, says x such that x is a counting number multiple of 2. So multiple of 2, so multiple of 2 will be 2, 4, 6, 8, and it keeps going. 10, 12, 14, ... It keeps going. Since we can't write them all because there's too many of them, we use those 3 dots indicating that it keeps going forever and ever. Alright, the next one, the set of all positive integers powers of 3. Powers of 3. So this is the same thing as saying, I'm going to write it right here. 3 to the 1, 3 to the second power, 3 to the third, 3 to the 4, 3 to the 5, blah, 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 right? So if we figure out what this is equal to, 3 to the first power is 3, 3 to the second is 9, 3 to the third is 27. Now remember the powers, you don't multiply the number times the exponent. Because a lot of students will say, well, 3 to the second power is 6. No, that's not correct. 3 to the second power means 3 times 3. 3 to the third power means 3 times 3 times 3. Okay, so you multiply the base times itself this number of times. The exponent will tell you how many times you're going to multiply 3. So it's 3 times 3 times 3 times 3. 4 times in this case. Alright, so in this case that will give you 81. And it looks like it keeps going forever and ever. So we're going to put 3 dots at the end to indicate that this keeps going. Okay. Alright. So throughout the video, if at any point you have questions, make a note to yourself so that way when we do the live sessions, we can go back and answer any questions. Okay. Alright, so now we're going to write a set builder notation given a list. So now they give you a list and we have to write basically like number 3, number 2, and number 1 from here. Okay, we're going to follow the same pattern. You start with the braces, x, and then the such that after. Okay, so let's look at the numbers. It looks like it starts from -6, -5, -4, -3. And because it has ... that means the next one will be -2, -1, 0, and it keeps going to the positive numbers. So to write this, we're going to write x such that x is, it looks like it's an integer because we have negative numbers and it keeps going to the positive, is an integer greater than I'm going to say greater than the previous one, so greater than -7. You can say, there's many ways to write this. You can also say x is an integer greater than or equal to -6 because it starts at -6. So that will be another option to write this answer. Alright, let's look at this one. 2, 4, 16, 32. It looks like it's powers of 2. It looks similar to this one, but now base 2. So I'm going to write x such that x is a positive number powers of 2. And don't forget to close your braces. Alrighty, the next one, the set of all cars owned by students. Okay, so we can say, notice in this case they don't give you numbers, but we can still write a set builder notation. And we can basically reuse the statement, the description, and say X is a car owned by a student. Basically, whatever car a student owns, okay? Alrighty, so let's move on with some more terminology on the second page. It says the number of elements in a set is called cardinal number or cardinality of the set. The symbol N of A is written as N of A represent a cardinal number of a set A. If the cardinal number of a set is a particular whole number, then we call it finite set. So let me start highlighting some stuff. So this represents the number of elements. So every time you see N of A, so N parentheses capital A, is asking you for the number of elements, okay? And we'll see right now what that means. And then if the number of elements is a finite set, it's a particular number, then we say it's finite set. If it's too large, for example, when we have the 3 dots at the end, that means it keeps going forever and ever. That means it's too large, then it's an indefinite set. Okay? So right now, we're going to see the difference between them. It's easier when we actually try some problems because you can see the difference, okay? Alright, so there's 3 things we need to go over right now. Here we need to identify if the set is finite or indefinite. So, for example, number 8, we have a set that it says 7, 8, 9, 28. So that means the numbers between 9 and 28. But notice it stops at 28. So it stops at a particular number, right? We have a specific set of elements. I can actually count the elements that I have in this set. Now because of this is a finite set. Okay? The next one, if you look at the next one, notice we have ... at the end. That means it keeps going forever and ever. In this case, I have no idea how many elements I have. There's so many elements that I can't really count them. Okay? So in this case, it's not going to be a finite, it's going to be indefinite set. Okay? Alright, so try to figure out if the next 4 sets are either finite or indefinite. Okay, so pause the video and give it a try. And then check your answers. Alright, for this one, we have x such that x is an odd counting number. Odd counting number will be all your odd numbers that are positive. So we can say, for example, like 3, 5, 7, and it looks like it keeps going forever and ever. So in this case, I have no idea how many exactly counting numbers I have. So in this case, it's going to be indefinite. In this number 11, we have x such that x is a fraction between 60 and 61. Even though they only give us two specific numbers, the amount of fractions that you have between those two numbers is too many. There's so many fractions you can write. You can get smaller and smaller and smaller and smaller and smaller between those two numbers that it makes this set to be indefinite again. It's too many. X is a prime number. A prime number is a number that is only divisible by 1 and itself. So for example, 3, 5, 7, 11, 13, 17, and it keeps going forever and ever. So in this case, we have too many prime numbers. 2 is actually a prime number as well, that it makes this set indefinite. Alright, so let's look at the last one. We have 1, and then we have some fractions. We have ... in between, but you actually end at a specific fraction. So in this case, this set is finite. You do know exactly how many elements you're going to have in this set. Okay? Alrighty. Now, for the next part, we need to figure out the number of elements on each of the sets. So remember, this means, I'll make a note here. Number of elements. Alright, so in this case, n of A is equal to, you basically have to count how many elements you have. 1, 2, 3, 4, 5. And boom, you're done. That's it. That's your answer. We're going to do the same thing for the next one. We have x such that x is a month in the year. Well, how many months in a year do we have? We have 12, and that's the number of elements you have. Next one, x such that x is an element in a minute. It's a second in a minute. How many seconds do we have in a minute? And that's going to be the number of elements you have. So last time I checked, it was still 60 seconds in a minute. So there's 60 elements in this set. Alrighty, so the next one, we have a set. Remember, ... that means there's numbers in between. So it looks like it's only decreasing by 1. So -7, -6, -5, -4, -3, -2, -1, and 0. So how many elements is that? It looks like we have a total of 8. Make sure you double check. The last one, we have fractions. It looks like denominator is increasing by 1 because the numerator is only 1. Then we have ... that means we have some fractions in between. We have 2, 3, 4, 5, and it goes all the way to 30. But notice you don't have 1. So the number of elements in this case is going to be 29. Because you only have 29 fractions in this set. Alright, so let's move on with some terms, more terms. It says the symbol, and I'll highlight the symbol, means an element of or a member of a set. Okay? The same symbol with the line through it means not an element of or not a member of the set. Okay, this is similar to, like, I don't know if you guys remember, like the equal sign. This is equal to, but when you have a line through it, it means not equal to. So this is pretty much the same thing. This is an element of, not an element of, okay? So if it has a line through it, it's basically like the opposite or of what the symbol is, okay? The way you're gonna draw this, or you're gonna write it, is kind of like a E, I guess, capital E. So like this, and a line through it. Let's see if I can do a better job here. It says complete the blank with either an element of or not an element of to make this statement true. So basically on the first one, is 0 an element of this set? Do you see 0 in this set here? Yes or no? If you do, then 0 is an element of this, but I don't see it, so it's not an element. So the little like E with the line through it. Same thing here. You might want to pause here the video and try the next 3. These are pretty easy. And check your answers. So is 5 an element of this set? I don't see it either. So I'm going to say no, not an element. 12 an element? Yes, I actually see it right here. So 12 is an element of this set. And the last one, we kind of have to do a little math here. So because this is 1 plus 5, and we know that's 6, and blah, blah, blah. So the question is 0 an element of this? So we have 4, 2, this is 2, and this is 0. So it turns out the 0 is actually part of this element. So because of this here, this makes it a 0. Okay. Alrighty. That was pretty easy. I think this and the previous one where you had to find the number of elements are like the easiest things on this section. Alright, so let's practice this. Now we're going to have to go over equality of sets. So in this case, a set A is equal to a set B, providing the following 2 conditions. Okay, so it says every element of A is an element of B. And number 2, every element of B is an element of A. So that means pretty much they have to be identical, right, in order to be equivalent or equal. So on the following 5 questions, we have to determine if it's true or not. Are they equal or they're not, basically, okay? So let's look at so everything in A, so suppose we're going to call this one A. This is your set A, and this is your set B. So everything in A has to be in B. So 4, 6, 13, those are in set B, right? 4, 6, 13. So that is true. But then it has to be the other way around as well. So everything in B has to be in A. I see 0 here, and I don't see it on A. So therefore, in this case, those 2 are not equal. So this is false. So try the next 4 problems and check your answers with me. Okay, so the next one, set A has 8, and it says x such that x is an even counting number between 10 and 16. 10 and 16 numbers, even counting numbers between 10 and 16, that will be 12 and 14. And 12 and 14 are not 8, right? So this is false. Next one, I see a 2, a 12. I don't see a 28 here, so be careful here. They're switch, so they're not the same, so false again. Next one, x is a counting number greater than 35. bigger than 25, greater than. So that will be this, but then 35 is not on this one, on the first one, so it's false again. Alright, so the last one, SQYOD, ODQSY. So notice they are the same, but they're mixed. The letters are mixed. That is okay, because these elements are on the first one, and the elements from the first one are on the second one. So we're going to say true. Alrighty. So now for the last page, page number 4, we will go over this ones in class. We're going to try them together, and I will have more examples from this section. Okay, so thank you for watching this. If you have any questions, make a little note, and we'll answer them during our live sessions. Thank you.